Hi, nice to see you again. Today I will be continuing coding with ChatGPT for machine learning. Just to give you a background of what I'm doing, if you haven't watched my previous videos, I'm currently pre-processing data for training a machine learning model, in this case WaveTwip at 4K. Okay, so I need to create a bunch of functions that will take a video, extract frames from that video, and then extract the audio, crop the faces in the video, and put them in a nice folder structure like you see here. Okay. This code here that you're seeing, it was written by ChatGPT. I had very little input on it other than just giving a few hints of what I wanted to do. It was a good start. Okay, so with the relatively low effort, like within an hour, I think I've done potentially 1 day's of work, because playing with the FFmpeg is not normally easy. It's very fiddly because you have lots of parameters, but with ChatGPT, it was able to do that in one go. Of course, you always need to check what it has done. Okay, so I have that script working now. You can see here what it did. It took a video file, okay, from this folder here in sample videos. Okay, then it created a subfolder inside pre-processing splitting. Okay, and then for each video you have a subfolder. Okay, and then for each subfolder you have a segment. Okay, depending on the, basically as a parameter I provide the number of frames I want to subdivide the video in, right? So I want 5 frames per segment. This could be higher or lower depending on how I go about training the model, and it's also based on the hyperparameter tuning and to see what it gives you the best results. So this number is not necessarily fixed. Okay, it's not rigid. Okay, and then we have this target frames per second. I'm just right now assuming that the videos will be at 25 frames per second, but I can make this higher or lower depending on what I find works best. Okay, so we have those parameters here, and that's why we get these segments. Okay, so for this small video, seems like you only have like not much actually. So it didn't create, only had like a few frames. Probably need to check, but anyway, it has done all the things I wanted it to do. So it subdivided the video into folders, and then it extracted the frames. Okay, and then it also extracted audio. Okay, today I'll be writing another script which is used to be, I'm going to write another script that I will use for pre-processing the data. So I'll take each frame here and I'll crop it so that it only contains my face. Okay, that's one version. Okay, then I need to also take so I need one version of my face fully visible. Okay, and then I need to mask half of it. So I'm going to save 2 different copies of the image, one with a mask and one without the mask. Okay, so that's the goal of today. Within 1 hour, I want to do this within 1 hour. So to see how efficient I can be, we're using ChatGPT and GitHub Copilot. Okay, I need to, of course. Right, let's get started. So first thing I'm going to do, okay, so I have here my files. Okay, so ideally what I want to do is to create a script that goes through each folder here, and then for each frame it detects whether there's a face, and if there is a face it will crop it. Okay, the question is, what do I do with frames that do not have a face? And that can happen, right? So I need to have some kind of convention. I think I'm going to just skip it. So if a frame doesn't have a face, I'll keep the sequencing as it is now, But for example, let's say this frame doesn't have a face. I'm going to skip it. I'm going to omit it. Okay. Later on, in the future, I'll decide whether there's a better way to deal with missing faces. You know. But for now, I'm just going to keep this simple. Keep this simple until I know exactly what I need. Yeah, that's about it, right? So the script should be fairly straightforward. So I just want to see how much ChatGPT can do. So I'm going to give ChatGPT some instructions, okay? I'm using ChatGPT 4, of course, and I'm going to ask, hello. I'm going to be polite, just in case he gets mad at me. All right, so I need a Python script that processes a folder with many subfolders containing more subfolders. So I just want to make it clear. There is actually, okay, there is like a 3 levels of folder structure, but I don't want to make that too much of an issue, right? So I'm just making it a little bit more generic, okay? So containing more subfolders that contain images, okay? In JPEG format. I need to, so just to be clear, I already have the cropping function, and I forgot to mention it actually. So I'm just going to show you. I already created the cropping function, and I was experimenting with that the other day. So I can show you that I have Retinaface already does the cropping. Oh, actually, I kind of did this already, but it was similar. But then it was not based on the. I didn't actually take into account the frame rate, and I didn't. Yeah, I don't. There's no. Yeah, so I need to do this again anyway. But I already have a function that does the cropping, as you can see here. Okay, and this function is here. So let me just find it. I actually put that in here. I'll copy it later. So I have a function that is defining generate face thumbnails. This can take a video file. Okay, actually, I think I made it work with the directory. I'm pretty sure I had it working with the directory. Yeah. Before I record more, I need to check my sound. Sometimes. Okay, I think it's correct. You can hear me, right? Yeah? Okay, I think it's fine. Right, so okay, I did create a function which takes a video file and then crops the face. It basically generates cropped faces for each video file, but this is not actually, I need to rewrite this because I want to apply this function only to the frame now. So it shouldn't be too difficult. Okay, right. So I'm going to just tell ChatGPT that I will crop it with a function that I already have. So using an existing function called crop faces. Crop face. Okay, another important assumption is, for now, keep things simple. I'm going to assume only one face at once. Okay. In the future, I might be able to deal with multiple faces, but for now, I don't think about that. Crop face. Okay. I need to. Okay, so I'm going to just reread this. I need a Python script that processes a folder with many subfolders containing more subfolders that contain images in JPEG format. I need to crop the face using a function called crop face. Okay, which will generate a new image file with size a new image file containing the cropped face. And then I also need to generate another version of that cropped face, but with half of the image masked in black. Okay. Please provide me with a Python code to do that. Okay, so let's see what ChatGPT can come up with. Yeah. So it's telling me to install libraries. I have it. Okay, I already have this function, so well, actually I need to write that function, but let's do that. Okay. So it gave me some code. Mask half of the cropped face. Okay, so it's writing two versions of the image, adding an extension. So it's processing a directory. Okay, so it's looking for images, JPEG images. This is good. And now we have the main. Okay, there's no arguments. I could add it, ask it to add some arguments, you know, with argparse. Okay, so this is input directory. And then what about the output directory? Oh yeah, the output directory. Okay, let's assume right now that we're going to apply this to the same folder. Okay. Okay, this is good. Okay, can you add the ability of passing the input directory as an argument using argparse library? Okay, I will default it anyway, but it will be good to have the ability of changing the arguments so that I can call this from anywhere I want it to be called. Okay. Okay. And so before we actually start using this code, I'm going to work on the crop face. It's just a question of extracting the method I already have. So I'll pass in as an input directory, no, an input file, and it will return. It's a good question. What's it going to return? It's expecting it to return an image. sorry, here. Okay, it's cropped face is going to be what? A frame, yeah. So it's going to be a frame, an OpenCV frame, which I can return. Okay, I don't have to write it to disk yet. Okay, so we have here now argparse, so I can pass in as argument, and then I can actually set a default to this input directory. So it always defaults to the same directory. Okay, all right, so I have the code here. I'm going to take that in a few minutes. Let's first go into our cropped face function. I have some code commented out here because I might need it. I'll explain later what this is for. So I have here the generate face thumbnails, which currently takes a video file. Okay, I'm going to keep this function, but instead of, okay, I'm going to create a function which is crop face, and I'm going to pass in the frame. I don't think I need to pass in all these arguments. Okay, crop face, and it should return a face. Wait. At the end, it's going to return a face crop. Okay. Okay, I'm writing some code, but GitHub Copilot is also helping me. Okay, so equal crop face. Okay, and I'm going to come and extract this code. And now explain this code as well, like what is it trying to do. Okay. Whoop. Okay. Okay, so the code is here now. Now I need to pass in some arguments, right? So you can see that there is a frame, a face size. Okay, so we have a face size, a frame. So I take that frame, I apply Retinaface, detect faces, it gives me a response. I'm not deleting this code yet because this code will probably be useful. So just to give you an idea, this is actually detecting the mouth region. And the reason I want to know the mouth region is because of the lips. And the idea is to train wave to lip, the discriminator, we need to give it, actually it's not so much the discriminator, it's more the lip sync generator. We need to mask the area of the face which is which has the lips, so that the lip sync generator learns how to generate the lips. So we hide it so that it doesn't, it needs to guess it, right? Basically it needs to generate it with a gun. Yeah. And then I could actually just try and see if I can get away with just having, I could try just to mask half of the image, right? 50-50. Probably most of the times it will hide my lips. But then I also have the information here because this neural network, the Retinaface model, actually knows where the mouth is. It's not 100% accurate, but it's probably better than not having it. So we can experiment with that. Okay, right, so we have a function here, takes a frame, then it will detect the face. Okay, then it will check for a face in the response. It can detect more than one face, as you can see here. I'm only worried about one face for now. So I'm only caring about one face. Then I check where the face is. These are the coordinates of the face. And then here what I'm doing I'm squaring the face because I'm going to save the crops as a square. Okay, a variable. I'll change that. For now, I'm going to keep it 256 pixel squares because that's what VQGAN actually is already. I've already experimented with VQGAN. By default, it will accept an image of 256 pixel squares. That's quite convenient. I'll probably have to increase that anyway. But for now, I'm just keeping this size. Yeah. So I'm going to square the image. Okay. And then to square the image, I check first of all which is the wider part of the image, and then I will I will only widen the the less wide part of the image. Heighten. Okay, that's a good word. Okay, and that's why we're doing this if statement here. Okay, and then we have. Okay, this is just some debugging, and then we do the crop here. Okay, and then what I'm going to do, I'm going to return face crop. Okay. Okay, so this is what I did. Crop face. So face crop. Oh, okay, and this has to go here. I need to make sure, okay, if there is a face crop, it might not be there. Okay, return, save it to disk. And then here, I need to also check if there is no face, I'll just return none, yeah. Okay, so we have now the function, face crop. I'm going to copy that into actually a script, which I'm going to create later. So I'm going to create the script crop faces.py. This will be, so I'm going to copy and paste this code that ChatGPT has created. Okay, we have now the code. I'm going to copy the crop face that I had in my notebook. Probably need some imports as well. So this is going to be where it's going to get a bit tricky because this function actually needs to use my GPU. So if I want to test it, I will have to probably, it will stutter the image. I will probably either have to pause the video or not talk for a few seconds until the function is finished. Yeah. Alright, so crop face is there. Okay. Crop face. And I need to just go and get the imports. Import CV2. Just already there. We have what else? Okay, can I just Retina Face. So JSON is also there. Not sure about requests. I'm just find the code again. Retina Face. What is Retina Face? Okay, this one. So I just have to copy and paste this. Okay. So I have now the code. I'll define a default for this. Okay. So default. Just make it a little bit. break down the lines so it's more readable. And then I'm going to specify, okay, okay, this is just some random folder. I'm going to set the folder based on, okay, I'm going to be running this from here. Data, pre-processing, and then splitting. Okay. I don't know what that is for. No, I don't need that. I don't know what that console is for. Okay, so we have a default value for the input directory, so I don't have to specify it. And I'll try to run it. I'm already with Retinaface Docker container, I think. Let me just double check. So I can see it from here. No, I'm using VQGAN, so I'm going to swap this to Retinaface. So I'm going to rebuild the container. As you can see, I have another video where I explain how I do this. I do everything inside VS Code. I use Docker containers, and I can switch between different Docker containers depending on what I need to do. I could also have the more than one Docker container open at once, but for now I prefer like this. So now, this is fairly quick actually. So this has TensorFlow. Retinaface uses TensorFlow, and I think now I might have to pause the video when I try this. Let me just, I need to raise this a little bit. Okay. All right. So what are we going to do? So I'm inside. So I need to go inside. So let me just find what directory is that I need to go. A source, pre-processing. Okay. So I'm going to run this script. Crop faces.py, just like that. And I might have to, that's going to cause me to stutter. Let's see what happens. Right. Okay, so it has failed. I'm hoping you can hear me all right. So it has an error. Okay. First of all, let me see if it actually generated anything. I can see there are some faces here. So let's have a look. Okay, so we have, nothing seems to have, oh no, this is the old one. So pre-processing. Okay. Oh, it seems like it has done something. It just failed for whatever reason. I'll find out why. But like you can already see, it's doing the cropped face. Okay, I didn't tell. To be fair, I didn't tell ChatGPT which it should be only the bottom half of the image, but I wasn't very specific, but I'll fix that. But actually it's not bad. Okay. So I need to understand why it failed here, for example. So what exactly happened? Line 75. So image is empty. So obviously it returned an empty crop face, but I can do that by doing an if statement. Because yeah, it's expected that sometimes the crop face will not be there. Okay. And might as well fix the issue with masking. Let's see if I understand this code that ChatGPT wrote. You can see it masked the width. Okay, this was a smart. Ooh, it's very. So I'm going to guess that it's going to be the height. This is a cool. Honestly, I wouldn't have written it like this, but this is actually quite a nice, smart way of masking an image. So I'm learning something new. Right, let's do the height divided by 2. Oh, this is more easy than I thought it would be. This is good. Okay, this is easy life. Did I just... What was there here before? Yeah, it was just... Okay. Okay, let's see. I want to make sure I don't mess it up. Okay, the actual... I see what's happening here, so it needs to be like this. So this is taking... Anyway, we'll see. It's basically taking half of the array and applying 0 to it, which is to make it black. Oh, or the opposite. Okay, we'll see. All right, so let's try again. And I can't talk for a few minutes or for a few seconds. Let's see. Okay, it seems like it failed. Seems like I made a mistake. Okay, it has more than... It's an array? Okay, yeah, of course. Okay, so basically I know I've assigned a none to the case when there is no cropped face, so I'm just going to do this. Okay. I stopped it because I don't need to process all the information. I'll probably do that offline. So I hope you can hear me all right now. Okay. Right, so let's see what it did. I think it did what I wanted it to do. Okay, you see? Okay, now we have the cropped face and the masked face. Okay, so these are the two inputs. So what I'm going to do with this later, not today, in another session, I'm going to use this to train a VQ GAN I'm actually only interested in the encoder and decoder of the VQGAN. And the idea is I'm going to compress this image. I'm going to quantize it. Get used to that term. Quantizing means it's going to become like a tiny image, which actually you can't really visualize it because it's like it has a number of dimensions that doesn't match what the normal RGB image has, but it's much smaller. Okay, so I'm going to be using that encoded image to train wave to leap. In this way, I can actually achieve higher resolutions with lower memory consumption. Okay, and once basically the training is done, then I can decode it, and that's why we have the decoder in the VQGAN. Okay, why did I create these two images, right? In the original paper, they actually do the masking during the training. Okay, and that's because they are working with normal RGB images. But when you are actually encoding the image using an encoder, you can't mask that during the training. So you need to pre-train another GAN to do the same for you. Okay, so these two images, one is going to train an encoder which knows how to recognize full faces, and another is going to train an encoder that knows how to deal with the half masked images. Okay, that's the goal. Okay, I think I've actually achieved what I wanted to achieve here. And let's see how much time I had available, because I could do some extra. It took me only half an hour to do this. I could try and use information about the lips so that I could mask this a little bit better. And that's why I had some information here about. So let's go into this function here. See, it's currently doing half, but I could also use this information here. So this gives me the coordinates of the X and Y of the mouth on the left and the right. And you can see, I could actually just, I'm going to enable this, okay? So we can see how it looks like. I'm going to crop this, wait 1 second, because this is according. So if I want to crop this, I need to crop this after okay. I'm just going to add some extra a visual cue, yeah? So to see where the mouth is, okay? So we can tell whether it's actually worth or not including this in our algorithm. So I'm going to put some of this code back. Yeah, so what this is going to do, it's going to draw a rectangle around the mouth area. Okay, there's some padding I need to also enable. 1 second, what is the padding? So padding. Okay, let's just do a padding of go to 10. Doesn't matter. Okay, so let's see if this runs. It failed. And then 6. Actually, just realized I'm trying to do this before I even know for sure there's a face. Okay, need to add this code. Yeah. So let's see if it runs like that. Okay, I stopped it. Okay, I stopped it because I don't need to run this the whole for the full duration. Okay, so let's see what it did. Okay, so you can see the padding is not great, but it does give me coordinates, rough coordinates where the mouth is. But then I would say that in the original paper they did something similar to this. I think they masked half of the image and they were able to get good results. So I don't see any reason why I should really spend a lot of time trying to mask, to be more precise with the masking. Yeah. For at this stage, I don't have to. I can definitely make this work with a bit of effort, but then at this stage, I don't know yet if it's worth it or not. But the actual Retina Face model tells me where the mouth region is, and I can use that information for better masking. But for now, I don't think I want to do that. Okay, so I'm going to go back to that code and comment it out. And that's it. I think easy day for today. So we have, what is it? I'm just going to comment out the code. And I'll run this offline for all the images, and then I will have basically a data set of images of cropped faces, which I can use to train my neural network. So what's the next stage for this? So next stage actually is going to, I need to gather more data. I only have a few videos, for example, just to get this code running, and then I need to gather more data, and then I need to actually train the VQ GAN properly. That's one of the steps. That's for the lip sync discriminator that I need to train. The lip sync discriminator in Wave2Lip actually learns how to basically correlate the sound with the image. So it will be able to tell whether the sound corresponds to the sequence of frames I give it. If the lips are in sync. Okay. What can I do there? Okay, I need to do another function. This will be probably for my last session. I need to take the. You see, I have this audio here. It's currently in a format. I will need to convert this into a basically a MEL spectrogram, which is a different type of visualization of sound, which I can show you here how it looks like. I have it somewhere. So I'll have to create a MEL spectrogram. Okay, I don't have it here, but you can see it in my previous video on Wave2Lip. I try to explain actually how the model works, and I talk about the original paper and the new paper they've come out, which has no source code, and that's why I'm actually writing the source code, by the way. Anyway, you will go to that video and check it out, and you understand more about what MEL spectrogram is and what it is for. So I need to do this as well, so I need to extract the male spectrogram from the audio. But my only doubt is whether I need to do this now, or could I do that during the training. It's probably fast enough to do it during training rather than, I don't have to pre-process that, I think. But I can create at least a function to do it, so later we can use it during the training. Okay, all right. I hope you found this video useful, and if you liked it, don't forget to click the like button, and I'll see you again soon. All right, happy coding.